Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. I bid to Sir Ammar Muhammad Akhir as my panel for Research Project 2 today, and also to my beloved supervisor, Dr. Shamila binti Matali, and I want to say thank you so much for guiding me in this research project. Today, I'm going to present about my research project 2 entitled Co-combustion study via thermogravimetric analysis of raw and torrefied bamboo pellets with sub-bituminous coal. For the abstract, the aim of this paper is to produce a potential biomass energy material that is derived from the blending of natural resources which are between coal and torrefied bamboo pellets. Before I explain even further, I want to talk about the two types of energy. Renewable energy, and one more is the non-renewable energy. The non-renewable energy is called non-renewable because sooner or later it will be depleted. The examples for non-renewable energy are fossil fuel, oil, coal, and also natural gas. This usage of non-renewable energy gives a disadvantage to the environment, such as air pollution, water pollution, and also can cause harms to living things such as us. It can harm our health, the animals, and also the habitat. But the main problem that is caused by this non-renewable energy is global warming. This global warming problem has caught the eye of the researchers on how to overcome this problem. To overcome this problem is we have to substitute the non-renewable energy with renewable energy. The examples for renewable energy are hydroelectric, solar energy, and the one that I want to focus on my research project is biomass. Next, the torrefaction of biomass can be described as a mild form of pyrolysis at temperature typically ranging between 200 and 300 degrees Celsius in atmospheric pressure and an inert gas condition. This is the optimum temperature and optimum condition for the torrefaction process to occur. Next, common biomass reactions during torrefaction include devolatilization, depolymerization, and carbonization of hemicellulose, lignin, and cellulose. This is the effect that is caused by torrefaction. The torrefaction process produces a brown to black uniform solid product as well as condensable water, organics and lipids, and non-condensable gas, which are carbon dioxide, carbon monoxide, and CH4 or methane. Typically, during the torrefaction, 70% of the mass is retained as a solid product containing 90% of the initial energy content, while 30% of the lost mass is converted into condensable and non-condensable products. The system's energy efficiency can be improved by reintroducing the material lost during the torrefaction as a source of heat. This is the explanation for the process of torrefaction, and as it states there, the material loss can be reintroduced in the process as a source of heat. Finish with the abstract. Now we move on to the next part. For my research project, there are three problem statements. The first one is finding alternatives to produce energy without harming the environment. Number 2, producing energy with biomass. And number 3 is producing energy with bamboo pellets that is blended with adaro coal. And for the objectives for my research project, there are two objectives. Number 1, to produce and determine the characteristics of raw and torrefied bamboo pellets. And number 2 is to study the co-combustion of raw and torrefied bamboo pellets with adaro coal. For the research background itself is the heart of the project, because in this section we can see the elaboration more based on the research that have been done by other researchers that is under the same topic and scope as my research project. For this research background, I have 2 points, which are first, blending of biomass and coal. Next is biomass treatment technology. For the first point, many technologies have been developed for the possible utilization of coal with biomass, such as co-combustion, co-pyrolysis, co-gasification, and co-liquefaction. Co-combustion is a promising short-term option for the application with the renewable fuels. Several reasons can be listed for blending biomass with coal prior to burning. The co-combustion of coal or biomass blends will help to reduce the consumption of fossil fuels. Sometimes, biofuel is mixed with coal to achieve better control of the burning process. In co-combustion processes, a volatile metal yield greater than 35% is sought in order to provide a stable flame, which could be attained by using biomass. From this first point, we can see that blending of biomass and coal will give a better energy value compared to without blending. And next, this blending can also reduce the consumption of fossil fuels. We move on to the next point, which is biomass treatment technology. Before I explain about this, I want to tell about the definition of biomass itself. The definition of biomass is organic material that comes from living organisms such as plants and woods. This material is called feedstock. The feedstock consists of plant material, woods, and also waste product. Okay. Bamboo is a challenging fill material, and most thermal conversion processes have strict fill specifications that are difficult to meet with biomass streams. Bamboo is hard and fibrous, which makes grinding difficult and costly. Moreover, the specifications with regard to storing, handling, and degradability are not an easy part for biomass in general. The thermal pretreatment torrefaction is dependable upgrading technology that can enhance by the field quality. From this second point, we can say that bamboo is a hard and fibrous material. So, the thermal pretreatment or torrefaction process is very much needed in order to harness the energy from the bamboo itself. For the recent application, this part will show about the application for the technology used in today's time. In this recent application, I have highlighted 2 points, which are torrefaction technology and biomass technology. For the first point, from a research study done by T.O. Rodriguez et al., torrefaction is an effective treatment for boosting energy levels in wood. From this study, the thermal treatment caused significant changes in wood properties. The temperature of 220 degrees C was insufficient to cause changes in bulk density in relation to the control treatment, while as regards the other properties, changes were not very significant. From this sentence, we can see that the wood energy content will be enhanced after torrefaction process is applied to the wood. Okay, next, the temperatures of 200 degrees C and 280 degrees C produce fuel with better energy properties than that of the feedstock wood. These temperatures increase the higher and lower heating values. This is useful in determining the heating value of the torrefied wood. Moreover, there was no influence of moisture. Effects on the energy density indicate that the temperature of 250 degrees Celsius is the most effective temperature, which means 250 degrees C is the most optimum temperature in yielding high energy. For the next point, biomass technology. As we know, the development of biofuels has been considered as an important step in preventing carbon dioxide emissions, suppress the deteriorated atmospheric greenhouse effect, and prevent global warming problem. As we all know, biomass will biomass can solve the problem that is caused by carbon dioxide emission, which is global warming. Thermochemical conversion processes are considered to be the most successful forms in which torrefaction has the lowest possible cost of global warming to generate biofuels from biomass. Combustion is also the cheapest method of burning biomass that can be burned alone or co-fired with coal to generate heat and electricity. We move on to the second last part of my presentation, which is the future prospects. Future prospects for co-combustion of torrefied biomass with other coal. The first point for my future prospects is further research or experiment needs to be done to encounter the challenges effectively. This first point means that, as we know, my research project is the feedstock is bamboo, and bamboo is a very hard and fibrous material. This first point means that we must find the suitable temperature and also avoid wastage of heat in the processing of the reaction with high temperature. Next, the blending between biomass material and coal is one of the best alternatives in producing energy. Okay, next we move on to the conclusion. In conclusion, the torrefaction is one of the processes that has caught the eye of the developed countries in harnessing energy from the biomass materials such as bamboo. Torrefied biomass, the main product of torrefaction, can either be used for the generation of electricity, but often by co-firing with coal or as first step in the gasification of biomass. This therefore clearly demonstrates that the production of biomass energy combined with coal can be one of the ways that can potentially help in the future, as well as energy and electricity in addition to the other renewable energies such as wind power, hydroelectrical power, and solar energy. I think that's all from my presentation today. I hope you enjoyed my presentation, and I'll be hearing from you soon in the Q&A session. With that, I thank you.